The problems facing the Americans were enormous. They were designing a submarine to launch these missiles from under the water. No one had ever fired a missile through the water before.
Rocket engines need air to burn, so they won't work underwater. So the engineers consider using compressed air instead.
So we have here a demonstration that Tristan's going to show us. Missile tube, compressed air, all we need is a missile. So I place the missile in the missile tube.
3, 2, 1, fire.
Thank you very much. But that's not very representative, is it? Because clearly the submarine is going to be underwater, so the tube will be full of water. This is a much more realistic and representative setup, where we've got the missile in the tube on the whole rig underwater. So the missile has to not only get through the tube, but also has to overcome the depth of water and the pressure above it. So Tristan, let's see what happens.
Ready? 3, 2, 1, fire.
So, rather disappointing. So what's the solution? Here we've got an arrangement where the missile is sitting in a dry tube with a seal on top of it. Question is whether that creates enough momentum where the missile breaks through the seal, whether it can get through the water that sits on top of it. Tristan, let's see what happens.
Okay, ready to fire? 3, 2, 1.
So clearly, that's the system that works.
These missiles are so big, they need more than compressed air to get them through the water. The Pennsylvania uses a small rocket fired into a tank of water. The water superheats and instantly turns to steam. This column of steam propels the missile through the water into the air. The nuclear warheads on this submarine alone are more destructive than all the bombs dropped in both world wars combined.